Hey, everybody, and welcome. We're diving into the world of image mining today.
Yeah, such a cool field.
It really is. It seems like you're pretty interested in it. And you've given us a ton of really cool research to look at. We've got everything here from a 1998 research paper called Image Mining, a new approach for data mining,
Hmm.
to a bunch of more recent surveys and literature reviews, some even from just a few years ago. So we're going to really chart the evolution of this field,
Yeah, it's changed a lot.
definitely. So before we get too far, what is it about image mining that drew you to this topic?
I think it's just so cool what you can do, looking at images like their data. Imagine looking at a satellite image and
Right.
being able to figure out like deforestation patterns or something like that.
Yeah, that's amazing. Or even in healthcare. They're using it to like spot diseases early from scans.
Absolutely. And it can be used for more than just serious stuff too, like understanding customer preference from just product photos.
It's crazy. The possibilities seem endless. So let's break it down a bit. What actually IS image mining? Like, what makes it different from just looking at pictures?
Well, it's about extracting knowledge from images. It's like
Hmm.
you can think of it like data mining, but instead of working with spreadsheets and numbers,
Right.
you're dealing with pixels
Right.
and colors and textures and
Oh,
shapes.
that's interesting. So you're looking for those connections and patterns that our eyes might miss just by glancing at something.
Yeah. And that's where it gets really cool. And it's been around for a while too. One of the first papers we have here is from 1998, which is kind of crazy to think about.
1998. Wow. Were they even using digital cameras that long ago?
Haha. Well, some people were.
True, true. Okay, so what were they doing back then with image mining?
Well, this paper, they were really focused on finding associations between objects and images, and they used like a synthetic image data set for their research.
A synthetic image data set. Okay, so they weren't using photographs, they were, what, making their own images?
Yeah, exactly. They were using geometric shapes and stuff like that to test their algorithms.
Oh, that's neat. So like instead of a photo of a cat, it's just a like a black blob or something.
Yeah, kind of like that. Although they do talk about how their algorithm really struggled to identify the letter L because it's a kind of irregular shape.
That makes sense, I guess.
Yeah, and it kind of shows how complex even those seemingly simple tasks can be for a computer.
Right. Like teaching a computer to see and interpret shapes like we do isn't easy.
Hmm.
So when we talk about image mining, what are the actual steps involved?
So you start with pre-processing, which is basically like cleaning up the data to make sure your analysis is accurate.
Okay.
So like you might need to remove noise from the image, adjust the contrast, or even just resize it.
Right. So just making sure it's all ready to be analyzed.
Exactly. Then comes feature extraction, which is where it gets really interesting. This is where you're identifying those key visual characteristics like the colors, the textures, the shapes, all of that.
So you're basically highlighting all the important parts for the computer.
Yeah, you got it. And this step is so important because the success of your algorithm depends on choosing the right features to extract.
So it's like if you're baking a cake and you forget the sugar.
Haha, yeah, exactly. Or you add salt instead of sugar.
Ooh, yeah, that would be
What a
bad.
total disaster, right?
Right. Okay, so we've got our image prepped. We've figured out what visual cues are important. What happens next?
Next, you need to identify and isolate the objects in your image, and that's where segmentation comes in.
Segmentation. So that's where you're telling the computer, okay, this is a cat, this is a tree, and so on.
Yep, you got it. And there are a bunch of different approaches to segmentation, but the main goal is to like accurately define the objects in your image.
Okay, I'm following you. So we prepped our image, we've picked out those key features,
Yeah,
and we've told the computer what everything is.
yeah.
Now what?
So now we get to apply data mining techniques to those features that we've extracted.
Ah, okay. So this is where you get to actually use algorithms and start making those connections.
Yeah, exactly. And there are tons of different algorithms out there that you can use, all depending on what you're trying to achieve.
So like if you wanted to group similar images together or
Right, or even classify images based on their content, like is it a picture of a cat or a dog, things like that.
that makes sense. But I imagine like working with images as data is probably a lot trickier than like, a spreadsheet or something, right?
Yeah, for sure. Images are way more complex than something like a spreadsheet full of numbers.
So what are some of the challenges that come up?
Well, one of the things is that like the values in images are relative. Like if you think about the color red, right? That could be a stop sign, it could be a delicious apple, or it could just be, part of a background pattern.
Oh, I see what you mean. Like the same color can mean completely different things depending on what else is going on in the image.
Exactly. And computers don't always pick up on that context like we do.
Right. And I imagine that can really throw things off.
It totally can. And then, of course, there's the whole issue of the amount of data you're dealing with. Image data sets are massive these days.
Yeah. I read that NASA's Earth Observing System generates something like a terabyte of data per day just from its satellites.
Yeah, exactly. So you're talking about a huge amount of information to process.
It's mind-boggling. And how do you even begin to develop algorithms that can handle that kind of volume?
That's definitely one of the challenges. We need, algorithms that are efficient that can handle that much data without taking forever.
Right, so it's not just about analyzing the images, it's about doing it quickly and efficiently too.
Exactly. And then on top of that, we have to make sure that we're choosing the right features to extract during that pre-processing stage we talked about earlier.
Right, like adding salt instead of sugar.
Uh-huh. Exactly. You don't want to accidentally sabotage your analysis by choosing features that aren't actually relevant.
It's like following a recipe but using all the wrong ingredients.
Exactly. And that's why this 1998 paper we talked about earlier is so cool.
Yeah, they were ahead of the game, weren't they?
Totally. They were already thinking about all these challenges and trying to find solutions.
Like what kinds of solutions were they proposing back then?
Well, one of the things they realized was that it wasn't enough to just be able to identify like individual objects in an image. They needed to be able to uncover associations between objects.
Oh, that's interesting. So it's not just about saying, okay, there's a cat in this image. It's about figuring out, like, is that cat sleeping? Is it playing? Is it about to knock something over?
Exactly. It's about understanding the context of the entire image.
Oh, that makes sense. It's like the difference between just reading a list of words and actually understanding the story those words are telling.
Yes, that's a great way to put it. And one of the examples they used in the paper is a grocery store, which I thought was really interesting.
Oh, yeah, like figuring out which products people tend to buy together.
Exactly. It's like in a traditional database, you might look at purchase history to see what's often bought together.
Mm-hmm.
But how do you do that with images, right?
Yeah, that's a good question. How do you do that with images?
That's where image mining comes in. You could potentially analyze pictures of people's shopping carts or even just images of their pantries to try to find those patterns.
Oh, wow. That's really cool. But I imagine that requires like a really high level of accuracy when it comes to identifying the objects in the image, right?
Absolutely. Remember how they mentioned their algorithms struggling to recognize that letter L?
Yeah. And I bet it's a whole lot harder when you're dealing with real world photos instead of just like simple shapes on a plain background.
Definitely. Real-world images are way more complex, and there's all sorts of things that can throw off the analysis, like lighting or weird angles or objects that are partially hidden.
Oh, yeah, I hadn't even thought about that. It's amazing that computers can even do this at all.
It's pretty incredible, and one of the things that's really been driving progress in this area is the development of deep learning.
Ah, yes, deep learning. Everyone seems to be talking about that these days. How is it being used in image mining?
Well, essentially, deep learning algorithms are like super-powered learners, and we can train them on massive amounts of data so that they learn to recognize patterns and identify objects with incredible accuracy.
So they're kind of like learning to see the world the way we do, but on a much larger scale.
Exactly. It's a really exciting area of research.
Yeah, it sounds like it. It's amazing to think how far we've come from those early experiments with geometric shapes. What else is in store for the future of image mining?
Oh man, there's so much potential out there. I mean, we've talked about satellite images and medical scans, even grocery stores, but there are so many other areas where this technology could be huge. Like one area that I think is really interesting is multimodal mining.
Multimodal mining, that sounds intense.
It is, kind of. It's basically where you start combining image data with other types of information, like, text, audio, sensor data, that kind of thing.
Oh, wow. Okay, so instead of just looking at a picture, you're adding like layers of context on top of it.
Exactly. And that can give you a much richer understanding of what's going on. Like imagine, for example, you're analyzing social media posts. Instead of just looking at the images, you could also factor in the captions, the comments, even the hashtags to get a more complete picture of what people are saying and how they're feeling about something.
Oh, that's a really cool example. It's like instead of just seeing what people are posting, you're actually getting inside their heads a little bit.
Right. And that can be incredibly powerful, especially for things like, understanding public sentiment around a particular issue or event. Or even for things like marketing and advertising, figuring out what really resonates with people.
That makes a lot of sense. What about other fields, though? Like, could you use this in something like urban planning?
Oh, yeah, absolutely. Like imagine combining aerial images of a city with traffic flow data, noise pollution sensors, even social media activity. And that you can use all of that information to make decisions about like traffic patterns, public transportation routes, even where to put parks and green spaces.
Wow. So you could basically create a smarter, more livable city using this technology. It's pretty amazing.
Yeah, it's really cool stuff. And that's what I love about the future of image mining. It's not just about analyzing images in isolation anymore. It's about really integrating them with all these other forms of data to get a more holistic picture of the world around us.
Yeah, it sounds like a really exciting field to be a part of. But before we wrap up, I do have one kind of, I don't know, I guess you could say a serious question.
Yeah, hit me with it.
So we've talked about all of the amazing things that image mining can do, but are there any potential downsides? Like, are there any risks that we need to be aware of?
That is a great question. And honestly, it's something that we as researchers think about all the time. Like any technology, image mining has the potential to be misused. So we have to be very careful about how we develop it and how we use it. Like one of the big concerns is making sure that the algorithms we're using aren't biased.
Ah, okay. Yeah, like if you're only training your algorithms on a certain type of data, then the results might not be accurate for everyone.
Right. Exactly. So we need to be really careful about the data that we use to train our algorithms and make sure that it's diverse and representative of the real world.
Right. So it's not just about the technology itself, it's about using it responsibly and ethically.
100%.
This has been so fascinating. I feel like I've learned so much about image mining today. Is there one final thought that you would want to leave our listeners with? Something to kind of ponder as they continue their own deep dive into this topic.
Yeah, for sure. As you learn more about image mining, I'd really encourage you to think about the ethical implications of this technology, because it really does have the potential to shape the future in some really profound ways.
That is an excellent point. Well, thanks again for taking this deep dive with us. I'm sure our listeners are just as blown away by all of this as I am.
It's been my pleasure. Always happy to talk about this stuff.
And to our listeners, thanks for joining us on this incredible journey into the world of image mining. We'll catch you next time for another deep dive.